Today we're going to be going over the standard operating procedure for the Zoller Pilot 3.0. Anyways, this is Zoller Pilot 3.0. It's going to finish loading here in a second, and we're going to see the startup screen. So first it's got to set itself for calibration. We've got a ball nose end mill in there. It's a 4 flute. So that's what we're going to be measuring. I am going to let the CNC do it. It's going to do, it says please select the mode in which you want to perform the reference movement. I let the machine do it. The referencing is now active. So now I just need to log in really quick to. Alright, now that we got that figured out, the password thing is done. Okay, so now we're here in the Zoller. Just going over a few things. So, not in the menu. In the help window, I was looking for information here in this little booklet. I went down to for measuring tools accurately on page 5, where I'm going to scroll down. This is just a little bit of information about the interface. This is the camera image. This is the dynamic crosshairs, which is that red that you see there. This is touchscreen, so make sure you don't touch this one. Then there's a tab that says the open modules. This is what you're in. And then it's the library buttons, the calibration adapter. And what I'm basically going to be messing with, is going to be the cutter shape, the measuring mode, and the cutters on the contour. Now, one thing I want to address is that before that, I'm going to be calibrating the adapter. Another thing before that is that I'm going to be measuring a tool based off of what I think is going to be the best measurement for the use, and I'm going to select that. So it's not going to let you do anything. You need to click out of this window before you start doing anything else. So for this cutter shape, because it's a ball nose end mill, I'm going to select number 8. Then for the measurement, I really want to know the top of it, so I'm going to use FC this time around. I can use N-C, but I'm going to use F-C. And then the number of cutters, the flutes, is 4. What we're going to do from there is I'm going to first go up to the top, and I'm going to let the machine calibrate itself. What it's going to do is it's going to find that area, and it's going to move the tool up as necessary. And you can see that it has moved down here. It's doing its measurements, and all I have to do is check that the Z is -4.795 and the X is 43.603. And now you can get a different measurement, which is going to be 87.206. That's just the diameter. Don't freak out. All you got to do is click this. See? Click, click, click. Okay, so as long as that 43.603 matches this one here, it does, and the -4.795 matches as well. It's calibrated. Perfect. Now, I'm going to move this tool up. I'm going to move it over. Oh. I gotta find myself first. Okay. Alright, now we're getting somewhere. Lots of blue. And we are finding the top of the tool, so I'm going to get as close as I can. To that piece. I'm going to also select this for finer movement. Okay, and now I'm going to let it find the tip. So it's going to search the tool tip, and it's going to measure it itself. So I don't really like that measurement too much, but it pretty much did it. So now I'm going to hit F5 which is going to actually do the measurement for me. It's going to calculate it. It's going to turn it around, and it's going to look at it. It's going to take 4 different measurements, one for each flute. That's going to take a minute. And then it's going to tell me the differences between the two, so I can know the offsets. I can see if there's any tool wear on any flutes, and I can tell if I need to make some compensation on my offsets before I put it in the machine. So it looks like it's taking its second measurement. Okay, second measurement being taken. Third measurement's in process right now. It's measuring. It's going to spit out another. Yep. So far it looks like I am looking at 100.463, 3.63, 4.85. That is a big difference. Alright, so what's wrong with my tool? It looks like the minimum dimensions on this ball nose end mill is going to be 100.359 thou. So, on the Z. And then the 485 thou is the other opposing dimension, the maximum. So the difference between the two is 126. That's pretty huge. This cutter is way out of tune. And it's in there pretty good. So that's not good. I don't think I'm going to use that necessarily for cutting anything precision. I'm probably going to be using that to just shore off material where, I can compensate for this. So the standard deviation on this is 57 thou. And that's just for the Z. That's top to bottom. So, there's some short flutes in there. So for the X, that's going to be on the width of it, right, the diameter. It looks like my maximum, my minimum dimension is going to be a negative 22 thou. The maximum dimension is 256 thou. That's a 131 thou difference. That's really not that good. So I'm gonna go back. I'm gonna check and see what I did. Yeah, that's not good. That's not good at all. So it's gonna tell me my data from what I pulled. This is my measurement data. My run out. Radial and axial, right, and then difference. I'm gonna run another one. I'm gonna measure by N-C, and that's just gonna be my next measurement. We're just gonna go through with that and then see how that does, and see what we get. So it's going to go back. It's going to focus. We're gonna look at this again. We're gonna let it run again, so you get to see it from not the computer side, but actually from this side. Even though it's going to give different measurements because it's measuring a different piece of the tool, because the setting's different. So I've got 2, 3, and we are doing the last measurement. It seems to be picking up the pace here. 4. Alright, so with this, we are still seeing some pretty high differences. 102 standard deviation versus 55 thou, and the 55 thou on the z-axis versus the x-axis. So obviously there is some discrepancy about what I'm going to be using this tool for. If I'm using it for anything precise, probably not, considering the difference. This is basically how you use the Zoller tool. This is my presentation for my assignment for the Zoller tool walkthrough, and thank you for taking the time to watch my video with me. I appreciate that. Thank you so much. If there's any questions, feel free to leave them in the comments. Maybe I can address them if there's anything that I missed. As for just closing up and shutting down, I am just going to go ahead and hit the exit button. I'm going to say okay, exit the program. Do I want to save my recorded data? No, not this time. It's going to go back to the main screen, and that's going to be the end of it. Alright, and thank you so much for joining with me for my presentation for this tool, this ball nose end mill. which seems to have quite a bit of wear. Actually, I can even tell just by looking at it that it has worn down. Obviously, it wasn't probably used entirely properly. We're just gonna put that back there. Okay, thank you. Just doing a recap here. So we have our Z right here. We have our X. This is the rotational position of the tool when it's turning. We have our tool here to move at a faster pace up, down, or diagonally. This is more of a precision move. And then what I ended up using in this system was the cutter shape, the measuring mode, and the cutters on contour. So just looking at that to recap, I used number 8. I used both the NC and the FC measurements, and I had logged 4 cutters so that when I did perform my automatic measurement of the tool, I was using the F5 function to measure. With that being said, the information was populated over here with all of my measurements, and that was yesterday. This is today.